Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. Today we are going to discuss storage devices. In the old syllabus, this was the second half of chapter number 6, whereas in the new syllabus, this is a part of section number 2, hardware. Okay, so there are 5 types of storage or memory. The first one is the primary storage or primary memory. Then we have secondary memory or secondary storage. Then we have offline storage. Then we have cloud storage and virtual memory. These two, cloud and virtual, have been recently added in the new syllabus, whereas these three things have been there since 2015 in the old syllabus. Then we are going to have a look at the further types of memory. When we are discussing primary memory, so we have 3 types available: RAM, ROM and cache or cache. There are 2 pronunciations for it. Some manufacturing companies call it as cache, whereas with e silent, and the others call it as cache. So it's really up to you, whatever you want to call. In our local market, this is also known as cache or CPU cache. RAM and ROM were there in the previous syllabus as well, whereas this cache is something new. This is basically a special type of memory. When we talk about secondary memory, so we only have 2 options. HDD means hard disk drive, and SSD, solid state drive. Offline storage then has further 5 types: CD, DVD, Blu-ray disc, flash memory, and portable devices or portable drives such as your portable hard drive. Knowing this hierarchy first is important so that we can go ahead and discuss each type clearly. There are 3 types of cloud storage as well, but they are not officially what you can say, they do not differ in the technology. They just differ in the type of users or the what you can say, the data is stored on the cloud in the similar way. There is no difference of technology, or the data is the server network is the same. The only difference is how many people can access it. So that is why I'm not labeling its type over here. We'll just discuss it when we come on to the topic of cloud storage, whereas virtual memory do not have any type. There is only one type of virtual memory. That being said, let's come to our first topic. The first thing in primary memory, that is RAM. Now, one thing which you should know about primary memory or primary storage is that primary storage is something that is a type of memory that is directly accessible by the CPU, or which is directly accessed by the CPU all the time. Let me just add that bit over here as well. Is accessible, or you can say is in direct contact of the processor or the CPU all the time. Okay, it is always in the direct contact of CPU or processor, no matter which type of memory we are talking about. Whereas when we talk about the secondary storage or the secondary memory, then it is not always in contact with the CPU. When you have to fetch a file from secondary memory, first of all it is transferred to the one of the components in the primary memory, either RAM or either in the cache, and afterwards the CPU is able to access it. CPU cannot directly read a file from the your drive, such as hard drive or SSD. First of all, the file needs to be copied into the RAM, and from there it moves to the processor chip through registers or cache, and then the processor or the CPU is finally able to read the contents of the file. Same offline storage is something when we talk about offline memory or offline storage, our offline storage is storage media that doesn't need to be plugged in or connected to a computer all the time. It doesn't need to be constantly fed some power, or it doesn't need to be constantly connected to a computer. Whenever you need to access the files on it, you can connect it to your computer or laptop, access the files, and then you can take it out without providing it any power. That is why it is known as offline storage. Okay, that being said, so the first thing which we have is in the list is primary memory, and the first sort of primary memory is a RAM. So first of all, we are going to have a look at RAM, and then ROM, and then cache or cache. So RAM stands for random access memory. It is a volatile memory, or it is a temporary memory, which means that it loses all its content as soon as the power is turned off. If you are working on an unsaved file and for some reason your PC is shut down, then you lose that file. When you are going to turn that PC back on, or your laptop back on, or your device back on, you are not going to get that file because it was there in your RAM. And because a RAM cannot hold something permanently, when the power goes out, RAM is cleaned off. It holds the data temporarily and provides it to the processor in pieces for processing. In place of pieces, you can also say in blocks. This is the purpose of the RAM. Since the CPU cannot directly access the files on the hard drive, the files from the hard drive are first fed to the RAM, and from RAM, block by block or piece by piece, that data is sent to the processor for processing. It is faster than other memories, but its volatility is a big drawback. Since it cannot hold data for very long time, then this is a very big drawback. The larger the size of the RAM installed, the faster a computer will work. The size of the RAM inside your computer is one of the key points which determine the performance or the speed of your computer. The more RAM it will have, the faster it will work. The lesser RAM your PC has, the more it will hang, the slower it will work. You have studied about buffers and interrupts. So buffers are often made up of RAM. Buffers inside CPU, buffers inside printers, inside your scanners, or any hardware device or any peripheral device which you can connect to the computer. If it contains a buffer, then remember that it is most likely made up of RAM chips. Now we have two types of RAM. One is the DRAM or the dynamic RAM, and one is the SRAM or static RAM. We'll get to the SRAM later on. First, let's discuss DRAM. Each dynamic RAM chip contains millions of transistors and capacitors. Now, transistors and capacitors are electronic devices, and I hope you have studied them in your physics, O-level physics subject. If you don't have, then that's fine, you don't need the technical details of these components. Just remember that each DRAM chip contains millions of transistors and capacitors. Now how does the transistors work? Transistors work as a gatekeeper. They allow a charge or data to be stored inside the capacitor or to go outside of the capacitor. Data is stored in form of charges. Now what does the capacitor do? Capacitor holds bits of information, basically charges, and transistors acts as a control switch for the information being held. DRAMs need to be constantly refreshed every 15 seconds or else they will lose the data. Because the capacitors which are used to make DRAMs, they cannot hold the charge for more than 15 seconds. So after 15 seconds the RAM is supposed to refresh, means whatever data was there, whatever data that was stored on the DRAM, it will all be erased and new data would be written onto it. They are less expensive to manufacture, they consume less power and have higher storage capacity. The next type of RAM which we have is static RAM or SRAM. Static RAM doesn't need to be refreshed constantly as they are made up of flip-flops. Flip-flops are a type of circuit that are made up of logic gates and transistors. They do not contain your capacitors. SRAMs are much faster than DRAMs because they do not need to be refreshed every 15 seconds. Processors memory such as cache is often made up of SRAM. They are more expensive than DRAM. They have less storage capacity. You cannot make let's suppose 2 GB RAM out of SRAM. It would be too much costly. Now this is an example of DRAM. This is something which you usually find in your laptop or your personal computer, whereas this is an example of SRAM. SRAM looks like this. Now SRAM is either found inside the CPU chip or it is found outside the CPU chip in form of cache, or mostly it is found in small programmable devices such as automatic microwave oven or automatic washing machines and other type of devices or remote control cars, where a larger RAM is not needed. The microprocessor chip inside the device only needs a few MBs of RAM. So over there we often have the SRAM chip inside toy cars, inside remote control operated equipment, inside automatic electronic devices and so on. The next type of memory which we have is ROM. ROM stands for read-only memory, and it is a form of non-volatile memory. That means it is a permanent memory whose contents can't be changed. They are used to store a startup routine of a system. For example, your BIOS chip is an example of ROM. When your computer starts, you see a black screen with some settings written on it, or you can go to the settings option and change where to boot from. That is known as the BIOS screen, basic input output setup, and that chip which contains this data is a example of ROM. This is the only thing about ROM which you need to know. There are types of ROM, but they are not a part of your syllabus, neither the old one or neither the new one, so you don't really need to know. Then we have cache. This is something this is a special type of high speed memory that is found within the CPU chip. It has been recently added in the syllabus. It stores data and instructions which are frequently needed by the CPU. The larger the cache size, the better the CPU will perform. Modern day CPUs have up to 3 levels of cache or cache to make performance faster. Usually level 1 and level 2 are inside the CPU chip, whereas level 3 cache is supposed to be outside the CPU chip in form of a separate chip besides the processor on the motherboard, which looks something like this. Now another thing which the examiner often gives and which you should know is the application of RAM and ROM in an embedded system or in a microprocessor controlled system. The examiner would give you an example of a toy car, or maybe a automatic washing machine, or a microwave oven or something like that, and he's going to ask you what is the application of RAM and ROM and microprocessor in this device. So always remember that RAM and ROM are used in many microprocessor control devices or toys for following tasks. RAM stores the factory settings. ROM stores the factory settings, startup routine, and set routines. For example, functionalities of buttons. Means those settings which have been decided by the factory, by the manufacturer, they are stored in ROM. That how to turn on the device, and when a user presses a button, what functionality would be launched, they are all stored in ROM, because the user cannot change it, or they are not supposed to change. Whereas RAM includes the user's customized instructions, as well as the instruction received from remote control or keypad before being processed. Whereas the work of processor is to act upon the instruction and perform whatever task the user has customized, or the user has asked it to do. Like for example, the user set a microwave to 2 minutes time, then the processor's task would be to keep on running the microwave for 2 minutes, or until the user cancels the time and takes out his dish from the microwave. The next thing which we have is, now we have secondary storage. And this before we start, just remember that this slide is very important from the exam point of view, and the examiner often asks this question about microprocessor control devices, and it always consists of two parts, that what is the function of ROM in it and RAM in it. So you should learn this up very carefully. The next we have are, like we discussed, after primary we have secondary memory, and we have two types of it, hard disk drive and SSD. And just remember that it is not in direct contact of the processor or CPU all the time, or it is just not in the direct contact of this processor or CPU. Whatever goes from the hard drive to processor, or from the processor to hard drive, it goes through RAM or cache. So what is the hard disk drive, or HDD for short? It is the most common type of storage media which is used inside your laptops or your computers, desktop computers. Data is stored on magnetic surface of disks, which are packed inside the hard disk with a read-write head. In fact, there are multiple read-write heads inside a hard disk drive. Data can be stored on both the upper and lower surface of the disks, or they are also known as platters. The read-write head can move very quickly to ensure quick access of data. Data is stored in form of sectors and tracks. A sector on a track contains fixed number of bytes, usually 4 MBs or per sector. They are slower than primary storage. Hence, larger applications which require multiple read-write operations in short times may cause the program to slow down or become non-responsive, while the read-write heads search for next block of data. However, they are inexpensive as compared to SSD. This is the internal diagram of a hard disk drive. Inside your hard disk drive, which looks something like this, there are multiple platters or multiple disks which are stacked on top of each other, 3 or 4 disks, and on the side of those disks there are read-write heads, one on the top and one on the below of each disk, because these platters or these disks are double-sided. Data can be written on top of it as well as on below it. If you view it from the top, then you would, this is a circular disk, and each circular disk is logically, not physically, divided into tracks, concentric tracks. Each of these circle is a track, and inside each track there are further divisions which are known as sectors, like this. And a combination of track and sector makes up one block of data. This is one block of data. This is a read-write head. Now when a program is installed, the hard drive is constantly rotating. The disk on the hard drive is constantly rotating. So when you start saving a file, each block has a specific number of bytes which it can store. Let's suppose you had a file of 16 MB. So 4 MB would be stored in this block, and then the next 4 MB would be stored in the next empty block, which may be over here or over here or over there. The adjacent, it almost never happens that a whole program or a whole file is stored on adjacent tracks. They are always scattered randomly because the disks keep on spinning. So when you try to run a heavy program, such as you try to open Adobe Premiere or 3D Studio Max or something very heavy, then it takes time because the hard drive has to look all the available blocks of data on its surface before it can completely run the program. So if the first block is over here, the second block of data is over there, the third is over there, fourth is over there, fifth is over there, sixth is over there, seventh to 14th is on this platter, and then 15th till 30th is on this platter. So it takes time for the hard drive to locate all the available blocks of data for a certain program, and then load it into the RAM and provide it to the CPU. Sometimes this can cause your computer to hang up and be non-responsive for a while. The next type of secondary storage device which we have is solid state drive or SSD, and it was designed in order to reduce this problem that the blocks of data are scattered all over the hard drive and it takes time to open larger files. They contain no moving parts such as rotating disks or read-write heads and consist entirely of NAND chips. Most of SSDs make use of NOR chips, which are much faster but costs increase. So there are two types of technologies when it comes to SSD. One consists of NAND chips and the other one consists of NOR chips. Now the difference between them is that in NOR chips data can be erased or read 1 byte at a time, whereas NAND chips can read or write blocks of data, means 4 MB or more than 4 MB in one read or write operation can be written. So as you can see, if you write 1 byte at a time and you write 4 MB at a time, so NAND chips become much faster. Thus two types of SSDs are available which are in the market, which are labeled as flash, which uses NAND chips, and EEPROM, which uses NOR chips. This one, if it is labeled, if the SSD you purchase from the market has somewhere written EEPROM on its label, on its box, that means it is much faster, and obviously it would be much costlier. There would be a difference of about 2,000 to 3,000 in the cost. They are more reliable, lighter in weight, consume much less power, they don't heat up because there is no motor or moving part in it. They are very thin as they consist only of chips, and they are much faster in terms of data access because all the files are stored together. They are not scattered on different platters or different disks. The cost is very high and they aren't much durable. They aren't much durable because there is a specific number of times you can read or write the data from the disk. After that, the NAND chips or NOR chips, they just become unresponsive or they just wear out. It is roughly 20. If you read or write 20 GBs of data per day, then your SSD would only last for maximum 3 years, and as soon as 3 years means 36 months time period is over, the hard drive, your hard drive or your basically your SSD, it would simply become non-responsive or it would simply die out on the very next day. This is a quick review of how inside of SSD and hard drive look like. This is an SSD, it only consists of chips, and this is a hard drive which consists of, this is the read write head, and these are the platters or disks is stacked on top of each other. There's a quick comparison. They have faster performance, no vibration or noise or no moving parts. They are more energy efficient, whereas they are cheaper per GB, means their cost is very low and as compared to SSD, and they are available in larger versions. It's highly likely that you would not find 2 terabyte SSD in the market, but you can easily find 2 terabyte of hard drive in the market. So we'll keep it till here today, and this completes our primary and secondary memory. We have discussed these three and we have discussed these two, and in the next lecture inshallah we'll discuss offline, cloud and virtual memory. Alright, this chapter is very important and it often comes in the paper, so please make sure that you understand everything. If you have any problem, feel free to ask me. Take care. Allah Hafiz.